we have gone from asking the question, is transfer learning possible, to asking the question, what does it take to be the best in the world at transfer learning?
Welcome to How AI Happens, a podcast where experts explain their work at the cutting edge of artificial intelligence. You'll hear from AI researchers, data scientists, and machine learning engineers as they get technical about the most exciting developments in their field and the challenges they're facing along the way. I'm your host, Rob Stevenson, and we're about to learn how AI happens. Joining me today on How AI Happens is the founder and chief technology officer over at Indico, Slater Victoroff. Slater, welcome to the podcast. How are you today?
Thanks so much for having me, Rob. I'm doing great. How about yourself?
I'm doing really, really well. I'm excited to get into this stuff because there's so much around the world of data that we can get into. And I've spoken to a bunch of AI professionals now on the show, and no matter what vertical they're in, whatever the application of their technology, a lot of them are going through some of the same problems. And like data is what comes up. Is there enough of it? What do we prioritize? Is it clean? How do we annotate it? Et cetera, et cetera. That's kind of where a company like Indico comes in. We'll get to that though. Before we do, I would love to just learn a little bit more about you. Would you mind sharing a little bit about your background and kind of how you came to found this company?
Absolutely. The way that I would explain the founding of Indico all comes back to something I said to a professor of mine in 2012. The war is over. Deep learning lost. Now, I call that moment the most wrong I've ever been. But, in 2012, it wasn't a particularly strange point of view to have. And right around that time, I was a sophomore in college, and, I had very luckily kind of contributed to a somewhat impressive paper in ML, kind of my first real attempt to contribute to the field. So, of course, at that point, I knew everything there was to know about the field. And I started doing calc competitions with a friend of mine. His name is Alec Radford, and the two of us would go on to found Indico. And for the first 6 months, we were really using these traditional ML techniques, right? XGBoosts and regressions and, the traditional kind of scikit-learn sort of stuff. But Alec had this notion in his head, for a very long time that there was something a lot more interesting and appealing in deep learning. And of course, me knowing everything in the field, having already written it off, I said, that's cute. You'll go play in your corner and I'll be over here doing the real work. And something interesting happened after the first 6 months or so, which is that the traditional techniques we were using stopped being effective. And deep learning really started to come into its own, right? And this sort of after AlexNet, right? So we've got some sense that this is possible, but really, actually, after those first 6 months, the traditional techniques never won again. And something that I thought at first, maybe this is a sporadic, right? Maybe this is kind of a one-off. I started to realize by trying really, really hard to prove otherwise that deep learning really did offer this kind of step change in how we approached certain problems, right? And maybe to be clear, I'm not one of those people that believes deep learning is a sort of universal magic panacea, right? I'm very anti that camp. But deep learning is particularly useful for these sorts of unstructured use cases, image, text, audio. And it's an incredibly powerful tool that allows us to attack these use cases in a way that we fundamentally weren't able to otherwise. And now, for me, who's this huge language geek, once I flipped over to the other side, I was incredibly excited. I'm like, wow, these are amazing tools, right? I've wanted to know how to approach these sorts of problems for so long. So we said, okay, let's try to put this into the real world. Let's try to get some people to pay us for a couple of these projects. And what we found really, really quickly was that while academically this technology was really amazing, there were some massive barriers to actually bringing this into production in an enterprise kind of environment. Even when you had, a lot of hardware at your disposal, it was still very, very difficult. And that really was the genesis of Indico, was this question of, can we solve the problem of making this new technology more accessible? Now, we've been in business for close to a decade at this point, so there have been a few evolutions in the vision over time. In the early days, the most ambitious version of this we could possibly imagine was, we were making APIs for developers, right? We said, okay, you don't have to be a PhD, you don't have to be Alex Grzeszewski, right, to do this. You just have to be an ordinary developer. And over time, what has actually happened, and if you look at Indico today, we've really increased our ambition quite significantly. And I would say that the way that we're really trying to solve this problem today is empowering even non-technical users to take control of this technology in a way that is transparent and empowering, right? And I don't think pretty much anyone else is actually focused on that problem. Not just how do I deliver sort of a use case to these people, but how do I actually make this technology usable and transparent, right, to someone who doesn't have any technical foundation for it.
For a quick history lesson, Slater, would you mind explaining what happened that kind of unlocked deep learning and sort of made that initial comment you made that the war was over, deep learning had lost, so wrong?
It's a really great question, and it's a couple of things that coincided all at one moment. But to maybe first paint, what was the situation in 2012? In 2012, deep learning, which in some senses is quite an old technique, right? The first basic perceptrons were introduced in, I want to say, 1955. And, in some people's mind, deep learning is still those perceptrons, right? So a lot of the basic concepts had been around for a very, very long time, but for various reasons, and actually it's a host of reasons. Part of this is computation, part of it is the algorithms weren't very good, part of it is we weren't really sure how to benchmark these techniques, right? Deep learning just didn't work, right? In all of the ways that we measured AI, right? Deep learning, it was compute expensive, right? It was very power hungry. It was, not data efficient, right? And it didn't even get you to a good sort of place in efficacy. And it was so unpopular that actually there was a series of papers mostly coming out of MIT about deep learning is so stupid, deep learning is the worst, right? And that kind of happened all through the 70s and 80s, right? And all of this got to the point where it was so unpopular that there were really only 3 researchers and research groups in the world that were still interested in deep learning in sort of the early 2010s. And this was University of Toronto, University of Montreal, and NYU. Those went on to become the heads of, Google and Facebook's AI programs. But that was really the environment that we were in, where there's, this was like some really weird niche area, right? People have been working on deep learning for a long time. No one has been able to get it to work, right? We've got these other techniques that, in the way that we test these seem to work much better today. So why would I even spend the time to learn about deep learning, right? That's a dead end in my mind. But these 3 folks, and that's, Geoffrey Hinton, Jan LeCun, and Yoshua Bengio, it turns out they knew kind of better than everyone, right? They kept working and working and working. It was a series of these kind of incremental algorithmic improvements over time, right? And it's incremental such that a lot of those we don't even still use today, but they were really important getting these first networks working. And then one of the other really big breakthroughs was the GPU, which more or less overnight, though, it took a long time to figure out how to actually get your code onto the GPU and run these models. But there's this really nice quirk of math that means that the math that you need to do for deep learning is really, really close to math that GPUs are very good at. So it was like you got this 30, 40x increase in compute power, in a really short period of time. And in an era, right, where Moore's law has, been over now for quite some time, you're not seeing those kinds of bursts in compute power happening anywhere else. And it turns out that that really was the bottleneck for a lot of the historic deep learning techniques, is that we just didn't throw enough compute power at them, right? We just didn't actually give them a shot to work. And the big turning point there, this is why I keep talking about 2012, is the AlexNet paper, right? Alex Krizhevsky in 2012 had this deep learning entry to ImageNet just mop the floor with the competition. And a handful of years later, deep learning was so good at that competition that we had to discontinue the competition because we're so good that it's not even useful to look at this as a metric anymore.
Right. It was like when they blocked Jordan from participating in the dunk competition.
Yeah, it's just look, it's not going to be interesting if we look at it this way, right? We're too good. Exactly.
Yeah. So what is the application then of deep learning that Indico's using?
Yeah, so our focus really is on this human-machine interaction, right? Our philosophy is that deep learning really is critically useful in these unstructured use cases, right? So images, text, documents, that's very, very important, audio and things along those lines. And one of the things that's interesting, maybe just to take an example of contract analysis, right? There's a couple of things going on there, but one of the things that's really key is that when you think about the end use case for a contract, and there's going to be a lot of different ways you use a contract in your company, right? I might be checking the terms before approval to say like, hey, yeah, this is good to sign, right? I might have to do an audit of all of my historic contracts to figure out, hey, where do the data rights look like X, Y, or Z? Maybe I didn't think very much about that at the time. All sorts of reasons you might be sifting through a contract. Now, the problem is in all of those processes today, the way that they're traditionally done, it's kind of like you fill out a spreadsheet, you've got very little transparency into it. Probably Bob and Jill and Sue, right, all the people that are doing this process are all doing it in a kind of slightly different way. They're doing it in this extremely manual way. There's really no way for them, even though, again, deep learning theoretically works really, really well for these kinds of problems, there's no way for them to actually get this sort of AI intelligent assistance in the work they're doing, even though it's theoretically a really good fit. And that's really the gap that Indico fits into. The analogy that we use is almost like an AI-powered bionic arm for the knowledge worker. Basically, you load your data in, right, whether this is contract documents or pictures of trash or tweets, right? And you've got sort of a particular task that you're trying to do, probably extracting some data, routing some data, right? You've got a lot of different things that you can do in the platform, but some specific task. And then in Indico, you basically start doing that. And then we've got in the background a deep learning based model, and we'll talk about it in a little bit more detail. That's basically watching what you do and learning in a lot of ways, okay, how should this be done? How do I kind of drive consistency here? And how am I then going to help you do this in a much more efficient and effective way? And, obviously try to take as much of that work off your shoulders as possible.
Is that what is meant by quote unquote solving the problem of unstructured data?
That's exactly what we mean. When you look at how people traditionally break up the unstructured data scheme, like if I am X big company and I want to build a sentiment analysis engine, right? That's how people, I think, traditionally think about these unstructured use cases. Highly, highly fractured. Right? The question of exactly how you're going to get after that is actually pretty multifaceted, even though sentiment analysis is the most boring, basic, hello world kind of thing you can think of, right? It turns out everyone actually thinks about sentiment analysis a little bit differently. And believe it or not, if you're thinking about building any unstructured use case today, just because the traditional requirements for the amount of data you've got to label, right, the number of services you've got to plug in, you've got to have a data science team, right, you've got to have this whole compute infrastructure, right, it's actually about $10 million for the organization to get one use case into production at a relatively large company. Which is kind of nuts if you think about it. Now, to Google, where every incremental bit of accuracy on AdWords targeting, right, is just printing money by the truckful, right? That's totally fine, right? So $10 million for them, absolutely nothing to blow $1 billion to get a couple dozen of the world's best researchers. An incredibly profitable, brilliant decision for them, right? Not the case for most organizations, right? The vast majority of use cases, right, are not these 2 or 3 at the top that print money like ad targeting, for Google and Facebook. And so they have to approach AI really in a fundamentally different way than everyone after that. So really what we're doing from a structural perspective, if you will, is we're taking that average cost to build out a new unstructured use case down from $10 million in sort of this old, highly manual way of doing it down to around $100,000, right? Huge part of that is we need less data. A lot of that is, we're taking care of the ML ops and that piece as well, right? Obviously, you've got to have data annotation, things like that integrated into the product in order for that to work, right? But that's the net really of what our customers are getting.
Is this downsizing, shall we say, in needs of investment, in needs of hardware, indicative of where the space is going? When I look at the way other sort of technologies have progressed, a computer used to be the size of a racquetball court, and now it fits in my pocket. There's been this pressure to make things smaller, more affordable, more accessible. Do you think that is a necessary outcome for AI technologies, or will there always be some need for huge amounts of investment and huge amounts of resources at your disposal?
It's interesting in AI because I'm sort of two minds, right? Because I think the answer is sort of yes on both sides, in that I think you do see on the one hand, there is a lot of research being done around how can you make these models more efficient, right? On the other hand, when you look from the perspective of what is actually coming out, the vast majority of companies out there, right, it's sort of this big singular model mentality, right? You really don't see people dealing with this problem of how do I deploy 1,000 concurrent models, right? It's how do I deploy one model and have it process all of the internet's content? And I think that's actually really interesting. It's to your point, it's actually really different from how a lot of other fields have been going. While AI is becoming more accessible, I think that the heights are also growing in AI. So what I would say has happened is that we've instead, just practically, and this is where things sit today. I think they've probably sat here for the past maybe 2 or 3 years, but things very well could change. But it's more that we've adopted a consistent cost of an experiment. So we're sort of like, okay, we are okay spending maybe somewhere between 2 weeks and 2 months letting this model train. And then you back solve for, okay, what's the size of our data center? And you're like, all right, this is the size of the model that we're going to make. So it's almost the inverse today, right? Where I think you do see a really big consolidation. OpenAI, I think, is a great example, where you're building these really massive data centers to train up absolutely stupid sized models, really to understand, what happens when you do make things this much bigger. I don't want to keep going in that direction. Certainly making models bigger makes them better. You can't argue that. It is simply true, right? But I'm also a big believer in the lottery ticket hypothesis. The lottery ticket hypothesis is basically saying that the reason we're getting this incremental improvement from these bigger models is not because having a bigger model is fundamentally better, but rather because a bigger model is basically allowing us to randomly choose between more smaller models, right? And that, that kind of implies that there are better ways of creating these, of initializing these, and we just haven't necessarily figured them out yet.
Right. The smaller model was out there to be found. It just took more resources to be found.
Exactly, right? And I think that not that many people are focused on that problem today. I think people are aware that it is a problem. Obviously, Indico is extremely focused on it. I hope more people continue to be focused on it in the future. But I would say that the seas have not yet swung in that direction very far. I would still say maybe the world out there is 80% this $10 million per project kind of, sentiment analysis is crazy technology sort of worldview, right? Maybe now 20% of us have gotten over into this Indico mentality of like, you can build these out for $100,000, right? And, we're obviously even trying to get that lower, trying to make that easier, right? But I think that right now, when you look at a lot of the rest of the 20%, a lot of people are still struggling quite a lot to even execute on that kind of $100,000 sort of price point. In fact, to the point where the failure rate that you see in our space right now, or rather, I'll say the success rate of getting into production and actually having success metrics is 11% across our industry. Really bad. Indico, we're actually at 97% success rate in production. So we're very, very happy about that. But I think it goes to show that, it's a new market and people are taking a while. It is difficult to make this technology more accessible, and there's not as many people working on it as I'd like.
What does that number mean, the 11%? Like, one, I guess, where does that come from? And two, what does that represent? 11% of the time there's an actionable outcome from training through to production, or what does that refer to?
It is pretty outcome oriented. So maybe first, that number actually comes from a couple of different spots. It's confirmed, plus or minus a couple percent between Gartner and Forrester and HFS and a couple of other analysts. So it's actually, as disheartening as it is, it's pretty well validated. And really what that is the alignment between the initial expectations that are set for the project and what is eventually achieved in production, right? Often that comes down to some efficacy rate. Usually it has more to do with an ROI than anything. But I guess really the ultimate judge is whether the thing stays in production and whether the people who were part of it leave it in production and say that it achieved its desired goals. And so really what they're saying is that 90% of projects are not hitting that pretty basic metric. And to even break it down a little bit further, it's something like 60 to 70% of the projects are failing before they hit production at all. And then the remainder they're getting into production and then failing at some point in production.
Okay, got it. This barrier to entry then, this high price point and this high likelihood of failure, it means that AI is really only happening in exclusive, well-funded areas that can afford to fail. And in the same way as, again, with like the racquetball sized computer, it was a non-trivial thing to assemble that and to have processor power. Now processor power is somewhat of a trivial thing. So what is the commoditization that needs to happen in this field for opportunity to be more widespread? Is it data?
I think that it's a part of it, but I think that it's not sufficient, right? I think that data is maybe the easy answer, because certainly there is like a data future I can paint that would solve the problem, right? Yes, if there were like widely accessible data in like gobs and gobs and gobs for all of these things, right? That would be one thing. But I unfortunately don't think that is very practical, right? I think like a view where we're going to solve this by like generating more data, it's just not how I view it, right? And here's actually what I think is very interesting. I think compute, like you said, in pretty much every industry, compute is like a non-factor now. The exception is AI, though. And this is something that I think a lot of people don't recognize. I would say that by and large, AI today is not data limited, it is compute limited. It's the only field, I think, in software that you can say that of. But you can actually, even me as an individual, like on my laptop, I can actually collect more training data, but pretty trivially in like a couple of days, right? Than I could even use in a training regimen. Right? That's not even more than I could use in a training regimen. It's like I can and have created data sets larger than Microsoft could use even to train their models, again, in like a couple of days from a laptop, right? So there's enough data out there. We've got the internet, and the internet has a lot of data, and it's pretty accessible, turns out, right? But everything we do is compute limited, first and foremost. And then the second piece I would say is that we are supervision limited. So it is really this question much more about, it's business and non-technical processes around defining what does success look like? How are we actually supposed to do this process, right? And it turns out that's actually a very hard thing to do. And I would say that once you're in a situation where you've resolved compute, that becomes a limiting factor. And then like data sort of solves itself if you can get those two done.
Would resolving compute, would that remove the need to have clean annotated data, or does it just assume perfectly clean annotated data?
There's no situation in which you can remove the need for clean annotated data. But let me maybe refine that like a little bit, because I think a lot of people have maybe some mistaken assumptions there. The way that I would analogize AI is you are programming with data. So the thing is, like, there's no programming language out there that is going to mean that you don't have to write code. That's kind of what I hear when people ask that question. Like, do we ever have to not annotate? It's like, no, it doesn't make sense. You're kind of like missing the forest for the trees, right? And I do get people have this sort of notion like, oh, I just want it to like magically autonomously work and like do the stuff, right? But yeah, I think that's not quite the right way to think about it, right? I think if you think about it much more from the perspective of I am programming with data, there's a couple of pieces there that I think are missing if you think about the programming experience that we do today, right? And why AI really does end up failing in a lot of cases. So first and foremost is if I'm programming with data, I need to be able to debug that data. I think a lot of people have this notion that I'm going to go out and get some pristine labeled annotated data the first shot, and that's all going to be right, and I'm just going to train my stuff. I was like, it doesn't work. There's no possible world in which that works any more than you're going to write your program and have it run with no mistakes the first time. So I think that what people miss is, A, it's much more important to build tools around curating the data that you've got than going out and just getting gobs and gobs and gobs of it. You've actually probably got enough data, right? And that's then the second point, right, is that I think people try to combat quality with quantity, and that's actually a really bad strategy here, right? I think a lot of people misinterpret a lot of the research out there, and they say, like, if I've got noisy annotations, it's okay so long as I've got a lot of them. That's actually not quite right? Because your noisy annotation is still a definitive, assessment of truth, right? You're giving instructions in your messy data, just like you're giving instructions in code, right? So, having more code doesn't give you a better program. Instead, it's this notion of like, okay, how do I actually come up with an ML scheme where I have a terse language, so I need as little data as possible to define it, and I've got these really rich tools to debug the data that I've got and make sure that I'm actually instructing this and building this program in the right way.
So this notion of perhaps prioritizing data, less being more, as long as it is cleaner, as long as it's better annotated, etc., this originally is a computer vision problem, correct? In terms of determining which data to prioritize. Is that still the case?
The most influential paper for me, I think, in my whole life came out in 2014 called Visualizing and Understanding Convolutional Neural Nets by Zeiler and Fergus. I probably shouldn't say that, clarify they're one of our competitors now and, they're the CEO, but I think it was where we got turned on to this notion of transfer learning, right? And, this is, convolutional neural nets, obviously that is in the computer vision space. And that was where I think we got really turned into this notion that you can start training a model with this like very big broad data that actually, like the quality is not so important there, and then allows you to create this like very, very clean guiding data that's going to sit on top of that. And, they hit this amazing state of the art with just 6 examples, I think, of cats and dogs. They were able to set a state of the art in, telling the difference between cats and dogs with 12 examples in total, which is just like eye-popping. And I think the other thing that they really dispelled in that becomes key to this whole notion is this notion that deep learning is a black box, that it's unexplainable. I think, back in 2014, this paper is sort of the definitive guide to debunking that notion, because they basically slice up the network in, every possible way you can conceive of, right? They're like, all right, what part of the image is it paying attention to, right? How is it digesting that, right? What is it good at recognizing? What is it bad at recognizing? They're like, all right, neuron 52846 is the one that is recognizing this variant of beagle face, right? Just incredible detail. And what they really turned us onto, right, was this notion that maybe this was generically applicable. Right. Again, 2014, this was even a very cutting edge notion in computer vision. Right. I think that even as of 2018 or 2019, if you were building a computer vision model that wasn't fundamentally based in these transfer learning techniques, you were pretty far behind the times. Right. But I think it's only really today even that's even moved over into the natural language processing space. Right. When you think, BERT came out and GPT, right. These are all of these transfer learning techniques, in language in the same vein that you originally saw in computer vision back in the day. But it took years in a space moving at lightning speed, right, to really be able to move from image over to text. But that really was where the inspiration came. And now there's a very interesting additional evolution happening on top of that, where people are asking this question in documents, for instance. When I've got a complex table, or maybe I've got an appraisal of a house and, I have images of rooms in there, right? And I really want to be able to think across this visual information and this textual information. It's like very natural for humans, right? It makes sense that you'd want to do that. That's really kind of this next frontier though, right? This is where transfer learning is going next, is this idea. Can I actually take visual information and language information? Can I understand that together in a comprehensive way and then give you one interface to learn on top of that kind of consolidated understanding of the world?
So this shift, I guess, or refocusing into transfer learning, has that affected your own approach at Indico?
Transfer learning, when we were starting out, was Indico's big bet, right? We're like, transfer learning is going to be the thing, like, trust us, like, this is where it's at. I think, thankfully, we were right. I don't think anyone would question that, we were correct on that. But I think one of the things that's really interesting is that it's gone from sort of a buzzword into a really deep domain. So I think it used to be this question like, are you doing transfer learning? Or are you not doing transfer learning? Right now, everyone is doing transfer learning in some way, but it is as much art as it is science. And that's often how I sort of describe it, is that we have gone from asking the question, is transfer learning possible, to asking the question, what does it take to be the best in the world at transfer learning? And I think that, academia has kind of shown it's a deep enough space where that makes a lot of sense. I think the two things that have really come into crisp focus for us that support that, kind of around that, are one, machine teaching, which we've kind of implicitly been talking about this whole time. How do you supervise these models differently? How do you more closely align supervision with the way that humans teach each other, right? Because I think everyone would agree that that's better, right? And then the other one is multimodal fusion, which we were just talking about, which is this question of, okay, how do we actually combine different modalities like text and image to, again, it's all about let the human train the thing more easily. It's all about put more control in the hands of the people. It's all about explainability is useful insofar as it allows you to have control. And so, we believe, for instance, very much in twinning together those notions of, if you've got a notion of explainability, you've got to have some control panel for that on the back end as well.
Slater, we've covered so much ground here, and I want to cover just a little more before I let you go, but I want to indulge, the 14-year-old version of you that first started to get really excited and nerding out about this space. When you take stock of where AI is now and where some of the growing opportunities are, what gets you really excited about what we can see from this space in the short to medium term?
Well, maybe one thing I will say to all of the 14-year-olds out there is that when I was 14, I didn't know how to program a line of code. I did not know what AI was. So if you're 14, you don't know what you're doing, that's fine. I'm much more excited about AI now than I was at 14, which I'll take as a good thing, actually. I think that's probably a plus. But what I'm intensely excited about today, machine teaching is a big piece, multimodal fusion, obviously a big piece, transfer learning is a big piece. But to me, it is all in service of this question of how do you solve the human-machine interaction problem? We've gotten to the point where the algorithms are capable of things that were just impossible even a short amount of time before. And really, the research question is pivoted around this notion of how do we expose this to humans? How do we decompose problems in a way that is both straightforward for a human to understand and control, and also is then really effective for ML algorithms to learn from on the back end, right? And it's a great example of something that a couple of years ago, we were so far from being able to do something like that. It didn't even make sense to ask the question. I was like, this is crazy, right? Like, come back later. But today, we've got the signs that show like, this is totally possible. We've just got to do it.
I love that. Slater, this has been fantastic. Thank you for being here and sharing your expertise with me today. I've loved learning from you.
Thanks so much for having me. It was a total pleasure.
How AI Happens is brought to you by Sama. Sama provides accurate data for ambitious AI, specializing in image, video, and sensor data annotation and validation for machine learning algorithms in industries such as transportation, retail, e-commerce, media, medtech, robotics, and agriculture. For more information, head to sama.com.